Hi, I'm Joy Ebertz, and I'm a senior staff engineer here at Split. I'm here to talk today about how to think about splitting a monolith using service architecture and domain-driven design. So this is something I worked on in my previous company, which was Box, and I'm also helping Split to think about how we might use the same sort of structure as we do the same thing. Normally I give this talk to engineers, but it is very approachable. So don't go anywhere because this will give you good insights into how we're thinking about splitting our monolith and what some of the things your engineers might be thinking about. Okay, so what I'm going to go over today, first of all, what exactly do I mean by service architecture, like specifically for this talk, because it can mean a lot of different things. Why do we even care about service architecture? And then I'm going to talk about domain-driven design, which is also known as DDD, and then a little bit about layered architecture, and then how both of those fit back to the actual services themselves. So what do I mean by service architecture? So a typical SOA architecture has a bunch of different things. A request comes in on one side, you hit the API gateway, you're going to hit a bunch of other services, authorization, authentication, logging, blah, 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 databases. But of all of this, I'm specifically going to focus on the middle three sections. So this is typically where your business logic specific to your company would live. So why do we care about service architecture? If you have a monolith, like a lot of companies do, you know that it's very tangled code. And when we split it up into microservices, we don't want it to end up looking like this, right? We don't want to just add network latency into all of the mess that's already there. Another reason is around code repetition. So if you have a bunch of services and then one of them needs to build something special and then suddenly another one also needs to build the same thing and a third one needs to build the same thing, suddenly you have the same code living in multiple places, which also isn't great. You also don't want to have hyper-localized optimizations. So when you're solving a single problem, it can be easy to focus on solving that exact problem. However, later on, you might find you have a very similar problem that doesn't quite work because your original one was super optimized for that particular problem. So you want to try to think broader. And finally, obviously, we just don't want to end up with a bunch of different services looking like a bunch of different things. You don't want something that looks cobbled together and not cohesive at all, right? So how are we going to think about how we might want to break this up? If you have the front end at the top and the back end at the bottom, there's sort of two obvious ways you can break it. So the first is sort of these vertical slices, front to back, like a feature slice. And this is where we're going to talk about domains and bounded contexts. And then the other is this horizontal slices. And this is where we're going to talk about layers. Okay, so for those vertical slices, what is domain-driven design? DDD is an approach to developing software for complex needs by deeply connecting the implementation to an evolving model of the core business concepts. DDD is not new. It's actually been around since 2004. It was originally coined by this Eric Evans book, the blue one, Domain-Driven Design. And if you're deep into the community, people refer to these two books. They're sort of the two key books everyone talks about. They call them the blue book and the red book. So if you hear that, that's these two books that they're talking about. So what are sort of the principles behind domain-driven design? So the first one is business value or technical strategy. And the idea here is to really focus on solving problems for your customers, right? So like, as engineers, we often like to play with the newest technology or try to see how we can make something work. But this one really is saying that you want to focus on solving the actual business problems and not playing with the new technology. Obviously, if the new technology helps you do the thing, you should do it. But in general, you want to focus on the business problem. The next one is cross-functional collaboration. So this basically means that you should be working with a full layer of people in your company. And this isn't just designers and product and engineers. This also includes marketing, sales, like the whole swath of people. You want to be thinking holistically, cross-functional. The next one, I sort of alluded to this before, but this is big picture and not point solutions. So thinking broadly, thinking in terms of the whole thing, not just now, but in the future. It's like, what is the whole solution that you might be encompassing? And then obviously, it also encompasses a lot of general software best practices. So things like separation of concerns and simplicity. And the other thing is that it's always changing, it's always evolving. So despite the fact you might come up with specific domains that make sense right now, they're going to change, and that's okay. That's the way it works. Okay, so those are sort of the principles. Next, we're going to talk about some of the core concepts. So the first one here is domains and subdomains, and then we're going to talk about bounded contexts, and finally, ubiquitous language. So domains and subdomains. What is a domain? A domain is just a problem space. It can be any problem space. So for example, split is a problem space, so we're a domain. The problem here is that split is pretty big, just like I'm sure all of your companies, right? Like as a single engineer, I can't keep all of split and all of our problems and all of our deep customer interactions in my head at once, right? I can only deeply know one smaller section of that. And because of that, that's why we get into subdomains. We want to split the problem space into smaller chunks so that we can actually get deep. So a single person can actually understand their subdomain. And depending on how big the problem is, you might end up doing a few different cuts of this. Like typically they only talk about domains and subdomains, but honestly, when I was at Box, we broke it up 3 times, but you can easily imagine breaking it up more than 3 as well. So it might be even more. Okay, so once you have your subdomains, once you have your smaller pieces, there's really 3 different types of them. So the first one is a core subdomain. And a core subdomain is really your money makers. This is your special sauce. What makes you you? Why your customers buy your product? Why anybody cares? The next one is a supporting subdomain. So this is something that nobody's going to pay for, but your main product isn't going to work without it. So it's sort of the thing that props up and makes your main product work. And finally, we have generic subdomains. So this is like your IKEA furniture. It's the stuff everybody needs, but you can sort of just buy something off the shelf, plug it into your house, and it'll work great and look great, and everybody likes it. So generic subdomains are things like split, feature flags, authentication, API gateways, authorization. So a lot of these things that are sort of the same across any product, but you sort of need them in order for things to work. Another way to think about these 3. So if it's a core subdomain, you really want to put a lot of engineers on it. You definitely want to build it in-house because, I mean, if you're not building it in-house, why are people paying you? And you really want to make sure that it's something that you know is going to make money, and you want to make sure that you build it really well. You want to put the gold star on all of your work here. In a supporting subdomain, you're going to put a few less people on it. You're still going to build it in-house because, again, it's necessary for your core subdomains. Another thing that might qualify as a supporting subdomain is a new business area that you haven't proven out yet. You think it's going to work, you think people are going to pay for it, but you don't know yet. So that would count as a supporting subdomain as well. And finally, generic subdomains, ideally you put nobody on them, but I mean, realistically, you probably put a few people on them, and ideally you buy the solutions here. And the other thing here is that things can move between these categories. So just because it's a generic subdomain now doesn't mean that it can't become a supporting subdomain later, or even a core subdomain. I mean, I imagine that Amazon, when they originally did AWS, they didn't think that that was going to be a core subdomain, but it is. So you can see how things might shift between those categories. Okay, so that's domains and subdomains. So what are bounded contexts then? So if you have your structure here and you have your domains, ideally, you would hope that your actual code and features fit nicely into these domains. But realistically, it's going to look a lot more like this, right? Like you build something that's kind of not really related to this other thing, but happens to live in the same code because they're implemented similarly. Or maybe you have some feature that has a little bit of code here and a little bit there and kind of all over the place. So you end up with these actual code that doesn't quite map cleanly to domains. So this is where you get bounded context. Bounded context brings sort of close to the domain, but then aligns it back with where the code actually is. So if you want to think about this in terms of the definitions, a problem space is defined by a domain, which consists of one or more subdomains. Meanwhile, the solution space is defined by a domain model, which consists of one or more bounded contexts. So you can see these 2 things are parallel. One is just around the problem space, and the other one's around the solution space. Okay, so what are some characteristics of bounded contexts? So they have clear and controlled entry points, or APIs. The other thing about what makes that great is that then they can kind of act as black boxes to each other. So if I'm working in one of them, I don't need to know any of the implementation details about the other one, as long as I understand the APIs and know how to deal with those. So this means that you can have totally different tech stacks in each of your bounded contexts. There's obviously other reasons you might not want to do this, so I'm not actually recommending this, but it is a possibility in case it's something you need to do for some reason. And related to that, you would typically put a team or a couple teams on each of the bounded contexts, which again means that even if you have different tech stacks, it doesn't matter too much because one single engineer doesn't have to know, Node, MySQL, and Go. They only really need to know one of those because that's the one that they're dealing with. Okay, so that's bounded context. Next, we have ubiquitous language. So ubiquitous language kind of goes back to that cross-team collaboration idea. So the idea here is that everybody working on the same domain should be speaking the same language. This means that we're using the same terms in our actual application code, in our test code, in our specs and documentation, in our whiteboard discussions, in our marketing materials. It really should be all over the place. It's possible that your external documentation might be a little different than internal, but ideally they would be the same. This also means, though, that sometimes you might have two different subdomains that have overlapping terms that mean different things, because it's going to be hard to get a single ubiquitous language across. Maybe it's possible at Split, but like at a large company, you can imagine at like a Microsoft, it would be almost impossible to get a single ubiquitous language across all of their products. So this means that this is an example from Box, but we had, if you ask somebody what a file is, if you were in the content subdomain, which was sort of responsible for the main file structure, they would say that it's a container object that groups versions of a piece of content and enables file system capabilities, so being able to move or copy a file. Meanwhile, if you ask the storage team, they would say, oh, a file is a blob of customer data identified by a unique name. They think of it as the bits and bytes on disk. So you can see how these are a little bit different. Okay, so that was our vertical slicing. That was the domains. Now I'm going to move into the horizontal slicing, or the layers. Okay, so what is layered architecture? Layered architecture is a way of dividing up between front end, middle tier, and back end in order to optimize for decoupling and reuse. So you have your application, and then you have your business capabilities, and you have your foundational capabilities on the bottom. Those are the three layers. People are going to be quick to point out that there are also a bunch of infrastructure services. These often live off to the side. This is things like authentication, which don't really quite cleanly divide into these three, which is why they're sort of off to the side. First, let's talk about the application layer. Okay, so these days a common term for the application layer is backend for front end, or BFF. And the idea here is that you have clients, so like a web browser or a mobile phone, that talk to your servers. And ideally, if you're a front-end engineer, you want to make a single call to get all of the data exactly, but only exactly the data you need in order to render a page or to do an operation. So you're going to make that single call. However, if you're a back-end engineer, if you have your domain separated cleanly, you want to just send back the data responsible in one domain. So you want to make the front-end engineers make a bunch of different calls, ideally. And the problem here is that those calls are slow, which is why the front-end engineers want one call. This is where the application service comes in. So the idea here is that the client can make a single call to this application service, which is typically owned by the front-end engineers. So as they're changing the client, they also change the application service. And then once that call chain is inside of your data center, that makes calls to all of the other back-end services. And these are fast since it's already within your data center. So this means that there's one slow call and then a bunch of fast calls, which collects the data exactly as it needs and sends it back to the client. And then a lot of times they'll have a separate application service for each different client that you might have, whether it's mobile, whether it's desktop, whether it's something else. And sort of like I've been saying, but this allows them to package in the way that that particular service wants. So you might have one underlying image, but then the service is able to translate that into the version of that object that it needs. So they can all look vastly different. And then application layer, if you've ever worked with front-end engineers, you know that they move quickly. Things change a lot, things change often. So this layer tends to change a lot. Okay, next we have the business capabilities. So this is where your really complex logic lives. This is where all of the various things tie together. You would have business capabilities can call multiple domains. You might have something that stretches across a few different underlying domains in order to put together a cohesive concept. And typically, they're the features that you want to have a consistent experience across all of those different clients that we just talked about. For example, if I'm buying running shoes, I want to be able to have the same basic things happen if I'm on the website, or if I go into a physical store, or if I'm at a race expo, right? Like, I want to be able to pick out some shoes. I want to be able to give them my credit card, charge it, and walk away with shoes. And similarly, you want to be able to start this transaction on my iPhone, for example, and then pause it, and then assuming I was logged in, come back on my desktop computer later on and finish my purchase, and then get back to the shoes. So this allows you to do things like start on one client, finish on another client, have things follow you across different clients. This layer typically moves somewhat fast, not as fast as the front end, but still should be pretty agile, hopefully. Finally, we have the foundational capabilities. So these are really your smaller building blocks that enable all of your other capabilities. These are sort of the smallest cohesive pieces that make sense. Yeah, like I said, smallest pieces. Ideally, though, these aren't just a database object. There should be some code associated. So it's cohesive objects. So it's not just the bare minimum, but kind of the bare minimum that makes sense as a holistic concept. These also are going to be a single source of truth. These are your records. You want to make sure that one particular foundational capability has ownership over a single record. So this means that I shouldn't have two different foundational capabilities that both have a user profile, for example. We shouldn't be copying data across them. If one of them needs that data, it should be calling to get that data. Although, actually, you shouldn't have them directly calling. It should be a higher layer that talks to both of them. This doesn't mean that you can't have a concept of a user in two different capabilities. So you might have a user profile in one and user billing in another. This is OK. And in fact, they can use the same ID to access both. And this layer moves slowly. You actually want this layer to move slowly, because if you break something here, it's going to affect every layer on top of it, right? So you want to make sure that these things are built well, and they're solid, and they aren't changing very often. And then finally, the infrastructure services. Like I mentioned, these are sort of the special cases. They're often the generic subdomains, so those subdomains I mentioned earlier. That's typically what falls into infrastructure services. So how does this map back to main services? So in an example architecture, you have your clients. They're going to talk to an application service. So that's one service. And then you might have a business capability service and a foundational capability service. And these things the application service can talk directly to a foundational service. It can also talk to a business capability service. So these things are a little bit fluid like that. However, depending on your size, these might be a little bit too small. So it's also possible that you could do it where the business capability and the foundational capability services are packaged into a single service. The big thing to keep in mind if you do that, which is probably what most people will and should do, but the big thing to keep in mind there is you want to make sure you're still exposing the endpoints that you would have if they were separate services, because this really allows you to build together and combine pieces in a different way later on. So that was a whirlwind tour of sort of this middle layer of this architecture, like we talked about before. And just to recap, I went over some service architecture, what I mean by service architecture, domain-driven design, layered architecture, and then how that actually fits back to services. Thank you.